Hello, everyone. My name is Damon Rocha, and this is my hardware-based neural net project. I put it on this TNC 4.1 microcontroller to detect movement based on this IMU. So what happens is I boot this up. It goes through some synthetic training data that I put in here, and trains a neural net on this data to learn whether or not this IMU is going moving or rotating or being stationary. I had a fourth label, but it's not working very well, so we're just gonna act like it doesn't exist right now. This network is just a classification network based for 4 classes. Right now, only 3 are really working, but more or less it takes in the magnitude of the movement, magnitude of the rotation, and goes through the network to figure out whether or not the IMU is moving or rotating. I'll give a quick demo on that. So if I pull this serial monitor back up and I refresh this so it starts over. Okay, here we go. So the IMU initialized, went through training, and the training is 300 epochs, which is just 300 cycles of training on this 1600 samples of data. And then from here, the final loss is not really 0, but that's just it rounded down because we're only showing 2 decimal places. But it's low enough that it's going to be pretty accurate based off of the data I have. So when the model's ready for prediction, I just type in start, which I believe it's lowercase. No, it's all caps. And so if I don't move this, it's resting. I don't know if you saw that, but I wasn't moving at that time. Now let's run it again, and this time let's try doing movement. So it begins, I just move it back and forth, and even though it said rotation that time, let's try that one more time. All right, and the problem with it when I'm holding it is that I'm rotating it a tiny bit, so it messes things up just a small amount. But if I do the same thing, but I set it, well, let's just try flattening it out just a little bit. So we just go side to side. Movement, awesome. And then we'll do one more for rotation just to prove that it wasn't a fluke. So if I rotate it all around, and it picks up rotation. And these numbers you see here are the probability of it being a certain class. So this is rest, this is movement, this is rotation, and then this is movement plus rotation. This final class, I can't, with the data I have, it's hard to get it to pick up both at the same time. If I had more time, I think I could have done it, but I spent quite a bit of time building out this network. I more or less did the whole thing from scratch. It's because it's on this microcontroller, so I couldn't use any libraries. And so that took a good portion of my time in that, and then going back and forth between some testing data and then data I was trying to collect from the IMU itself. But at the end of the day, it ended up being a good proof of concept. I want to take this from this microcontroller and put it on a FPGA I have right here and use this to actually, the neural net, instead of being code, would exist on the circuit board itself, and the resistances and whatnot of the circuit board would end up changing based off of the architecture of the neural network. So in essence, I take this from being a program to actually being part of the hardware, and it would be able to change these hidden counts, inputs, outputs, max samples, and everything on the fly, instead of having to do this all through code and then me having to come in here and change it and upload it and everything. And that'll be what I end up trying to put on a rover in the distant future once I get this all working the way I want it to. And yeah, thank you very much.